Hello everybody, this is Elisa Baum, Percona's Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of housekeeping. Could you please raise your hand using the hand icon in the GoToWebinar control panel to let me know if you can hear me. And let me take a look. I see hands. Thank you very, very much. Next, you'll be on mute during this webinar, but if you have any questions, please go ahead and enter them in the questions field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible. And those that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL performance blog. In addition, a recording of this webinar will be made available to everybody within 48 hours. With that said, I'd like to thank you for attending today's webinar using MySQL 5.6 Global Transaction IDs in Production. Our speaker today is Stéphane Cobendon, and with that said, I will turn the floor over to you, Stéphane. Go ahead.
Thanks, Melissa. So, as you said, the topic for today will be Global Transaction IDs for MySQL 5.6. So the agenda will be first, an introduction to GTIDs, because I'm not sure everyone knows well, all the basic things you have to know before being able to put GTIDs in production. Then we'll see how you can operate a replication cluster with GTIDs. So, you know, the daily DBA task you'll probably have to do lots of time. Then we'll take a look at the typical issues you'll have to face when enabling GTIDs, and as one of the goals of GTIDs is to make things like failover and replication reconfiguration much easier. It means that GTIDs have lots of potential regarding high availability solutions. So we'll have a look at what's new when you have GTIDs. Now let's talk a bit about the basic things you have to know about GTIDs. So first, very basic things like what is a GTID? It is simply a unique identifier for a transaction. The thing that makes it different from a binlog file and position is that this identifier is unique for all the servers in a given replication setup. So if you have a transaction with ID 1 on the master, it's exactly the same ID on slave 1, slave 2, slave n, etc., no matter how complex the replication topology is. The main goal, of course, is to be able to change the replication topology very easily, because if you are DBA, you have probably at the issue of, oh well, replication is broken, I have to, so my master has crashed, replication is broken, I have to promote a slave and then reconnect the other slaves to the new master, and oh well, that's very hard. That may be very hard because you have to take the right binlog file, binlog position, it's different everywhere, it's a real mess. So with GTIDs, it should be much easier. So as you may know, it's available from MySQL 5.6. With MariaDB 10, we also have GTIDs, but the implementation is a bit different. The goal of this implementation in MariaDB is to overcome some of the limitations of the implementation in MySQL 5.6. The thing is that the implementation in MariaDB 10 is not compatible with the one in MySQL 5.6, and there is work in progress to allow that from the MariaDB team. It's not done as far as I know. And the focus of today is really GTIDs on MySQL 5.6. So how does it look like? For GTID, you have basically two parts. The first part is a source ID, which is the server UUID, and then you have a number, an integer, which is the transaction ID. So for instance, you have like 3E11, etc., colon 1, which means that this is the first transaction written for the server with UUID 3E11, etc. There's the mapping between a GTID and the actual binlog file and position, and it's kept in memory. We'll talk about that later. One other thing to know is what a sequence of GTID is. Well, it's basically a way of representing in sort of a compressed way a range of transaction IDs issued from the same server. So if you have server ID 3E1, etc., and you have transaction 1, 2, 3, 4, 5, you can, so MySQL 5.6 uses the notation source ID colon 1-5. Okay. This is what you'll see in show slave status, for instance. So now, how do you find the position of an event? Well, that's really easy, and that's the goal of GTID. So if you have a transaction with a given GTID on the master, well, then you know that it's exactly the same on all servers across your replication topology. So this is the main goal. One word about transaction ordering. So you have noticed that you have, with a GTID, you have a source ID, a transaction ID. So you have a transaction counter. The thing to know about this transaction counter is that it's per instance. It's not global. So for instance, if we have a transaction, so GTIDs XXX101 and XXX102, we know for sure that XXX101 was executed first because it's from the same server. But if we have GTID XXX101 and then YYY102, we don't know which one came first because it's issued from different servers, so the transaction ID is incremented independently. This is something to remember. Now, how do you enable GTIDs? You have to add a few settings in your configuration files. So you should do that on all the servers. So it's GTID mode equals on. You have to enable binary logging and also log set updates. And it's recommended, so not mandatory, but recommended to use enforce GTID consistency. Then the first bad thing is that you'll have to restart all the servers at the same time. So yes, unfortunately in MySQL 5.6 it's mandatory, so it means downtime. So you can try to, for instance, keep a slave, so restart every servers except one. If you do that, replication will break. So you really, you must really restart all the servers at the same given point in time. In 5.7 it's going to be improved. So 5.7 is far from being finished, so there may be well, a few surprises, good or bad. It will be improved, and for 5.6 we have Facebook and we have Booking that have published well, patches to allow online migration. But the real thing to know is that officially the only supported way to enable GTIDs is to take the downtime. And for instance, that's one of the things that is improved in the MariaDB's implementation. So you can allow enable GTID replication without downtime. So that's pretty good. Now, once GTIDs are enabled on all servers, you can go to your slaves and then use change master2 to enable GTID replication. So if you you only configure GTID mode equals on, the master will write GTID, but replication will use the regular position-based replication. So you have to go to all your slaves and run change master2 with master to position equals 1. And when you use master to position equals 1, you no longer need to use master pose and master file. So you'll probably have to do something like change master2, master host equals something, master user, master port, or master password, and then master auto position. Last thing for this introduction is the replication protocol. So in the past, when we were using position-based replication, what happened when the slave connected to the master? The slave simply told the master, well, now I want to connect to the bin logs from file XYZ and position 123. And basically, what the replication protocol did was to send all the events from that position, and that was all. With GTID-based replication, it's a bit different. So first, when the slave connects to the master, it sends the range of GTIDs it has executed. And then the master looks at this range of GTIDs and it will send back all the other transactions. So it may not seem very different. We'll see in a moment that in some situations it may be very different. And there's an additional rule in GTID-based replication, which is a transaction with a given GTID can only be executed once. So if you think about position-based replication, if you do wrong things like you position your slave to a position in the bin log that was already executed, well, there was nothing to prevent you from doing that. With GTIDs, it's not possible. So you only say auto position equals 1, and then the replication protocol and every part of the system is intended to avoid that a transaction can be executed twice. So we'll see more on the replication protocol later. Okay, so now we know what GTIDs are. We know their goals, of course. We know how to enable GTID replication. So now let's say that you have a replication cluster with a few servers and you have to operate it. So what are the tasks that you'll probably do from time to time? First thing is probably being able to provision a new slave. So there are different ways to do that, but I'd say that two of the most common ones are using MySQL dump or using Percona extra backup. So when you're using MySQL dump, you can still use -- master data to have a backup on the master. And if you're using this option with MySQL dump versions 5.6, it will include GTID information. So when you reload the dump, you'll be ready to use GTID replication. So the only thing that you'll have to do then is to use change master to with master to position equals 1. So that's pretty easy. With extra backup, it's pretty much the same thing. So you have the same extra backup bin log info file that we've always had, and now it contains both GTID information and bin log file and bin log position. So same for -- master data for MySQL dump. So you have the GTID information and you also have the bin log position. So for extra backup, you can look at this file, extra backup bin log info, extract the GTID information in there, and when you have moved the backup, so after you have restored the backup, you can run set global GTID purge equal the GTID you saw in extra backup bin log info, and then run change master to with master auto position equals 1. So there's nothing really difficult here. Next thing you probably want to do quite frequently is to check replication status. So for that, you'll use show slave status like before, and basically you have exactly the same information as before. So the two main things are probably do you have slave IO running equals yes, and slave SQL running equals yes, meaning that both replication threads are running. But we also have new columns in the output of show slave status, so at the end. For instance, we have retrieved GTID sets. So this is an indication of the set of GTIDs received by the slave which may be empty, for instance, after a server restart. You also have executed GTID set, which is the list of GTIDs that have been executed by the server. So here, from the picture we have, we know that the last transaction that has been executed on the server is so 4161, 631, etc. colon 7. Of course, this is executed GTID set is persisted after a restart, of course. And the next thing we have is auto-position, which is simply 1 if you're using GTID-based replication. So for instance, if you want to make sure that you're using GTID-based replication, so if you have a script checking for that or something else, you can probably look at the value of auto-position in show slave status. Okay, so we also have global variables called GTID executed, which also contains the set of executed GTIDs on a given slave, and this is exactly the same thing as the executed GTID set column that we have in show slave status. So as you can see in the first picture, we have show slave status, then we have show global variables like GTID executed, and we have the same value. One thing that you have to know is that so if you have a cluster, let's say with 3 servers, so the master crashes, then you promote one of the slaves, and then you may also want, for another reason, promote the 3rd slave to be the master for some time. Then the executed GTID set may look a bit more complex than the things I've shown in the previous slide. Like in the second picture here, we have, for executed GTID sets, a very long string. So basically we have 3 GTID sets, which means that the server with UUID 416289, etc. was the master for some time, but then we also had the server with UID 41631 DIF, etc., and then the 3rd server was also a master for some time. So this is something to keep in mind. For instance, if you want to use executed GTID sets in scripts, be aware that this string may be more complex than just server UUID colon transaction start, transaction stop. It may have several lines. Okay. Next thing you'll probably have to do more than once is to skip transactions. So with position-based replication, we have the famous SQL skip slave counter equals 1 or equals n. And main thing to know is that it no longer works with GTID replication. And the main reason is that the new replication protocol doesn't allow that. The reason is that if you would be able to skip a transaction, then because of the replication protocol, which makes sure that every missing transaction is sent from the master, it would search anyway. So there's no way to safely skip a transaction by using SQL skip slave counter. So that's why if you try to use it, you'll get an error. Of course, there is a solution to skip a transaction with GTID-based replication because you may need it. And the idea is that you will execute a fake transaction with the GTID you want to skip. And because of the replication protocol, as long as you have executed a transaction with a given GTID, it cannot be re-executed a second time. So if you have executed a fake transaction, well, it's going to replace the real transaction. So it's like skipping a transaction. So how do you actually do this? So if you want to skip transaction XXX:NN, first stop replication, so stop slave. Then you have to set GTID next with the GTID of the transaction you want to skip. And then you'll have to run begin commit. So this is where the fake transaction is. So it's an empty transaction. Then you set GTID next equals automatic, and then you restart the slave. And this is how you can safely skip a transaction. So, of course, it's a bit more complex than using the SQL skip slave counter equals 1, but, well, this is the only way to do that. Well, actually, this is not really the only way, but it's the recommended way. Let's say that. Okay, let's now look at the typical issues you may face with GTID-based replication. I think the most significant one is having errant transactions. So let me clarify. First, what happens if you execute a transaction locally on a slave? So, of course, you're not supposed to do that because all rights should go to the master and then go to the slave through replication. But, well, you may do a mistake, you may have a wrong script. Okay, there are many reasons why you may execute a transaction locally on a slave. So what it's going to do is that it's going to generate its own GTID, because each server, if you remember the options that we had to set, each server has a binary log enabled. So each server in the replication topology is allowed to generate GTID. So if you execute a transaction locally on a slave, it will generate a GTID. And if the slave is promoted, the transaction will be sent to all the servers, thanks to the new replication protocol, which makes sure that when a slave connects to the master will always send back all the transactions that are missing. And unfortunately, this can bite on failover. There are two main cases. The first case is that transaction is not desired. So you have executed a transaction locally on a slave. It was a mistake. If you promote the slave to be the new master, well, now your transaction will automatically go to all the servers. Then the other issue, and that may be more severe, is that if you promote the slave and if the transaction is no longer in the bin logs, well, this is a real issue, because then the transaction, so all servers will want to get this transaction, but as it's no longer in the binary logs, you'll end up with a replication error. So this is here the main issue with errant transaction. So an errant transaction is a transaction executed on a slave, locally on a slave. At failover, it has the potential to break replication, which is usually the last thing you want to do, because sometimes failover is planned, but most of the time I'd say that failover is when the master has crashed, so you want things to, so you want to failover fast, and the last thing you want to have is to break replication everywhere. So be aware of that. Of course, now that we know that errant transactions are potentially dangerous, we want to have a way to detect them. So to do that, it's going to be easy. So the idea is that the executed GTID set of any slave should always be a subset of executed GTID set of the master. And MySQL 5.6 provides a function to evaluate if a set of GTID is a subset of another set. And this function is GTID subset. So you can use that function for the check. So basically you run select GTID subset, slave set, comma master set, and if it returns 1, you're okay, and if it returns 0, you have one or more errant transactions. And to identify the errant transactions, you can use another function added in 5.6, which is GTID subtract. One thing that is not very easy to, so it's not always easy to work with this function because you always have to set correctly the parameters. So for GTID subset, the first parameter is slave set, and then the second one is master set. For GTID subtract, it's the opposite. So it's a bit, well, confusing, but it's very useful. As a side note, this check is quite easy to implement, but of course it only works if you're able to see the exact GTID set of the master. So it only works well if the master is online. So if the master has just crashed, and if you want to check if you have any errant transaction before doing a failover, because you know that errant transaction at failover time can break replication, it's a bit more complicated. So there is a procedure, I've not detailed it here, but basically you'll have to look at all the GTID sets on all the slaves, compare them, etc., etc. So it's a bit more tedious to do. Okay, last thing, when we have detected an errant transaction, how do we fix it? Well, the easiest way is to inject an empty transaction, so to skip transaction, on all servers of the topology. And if you have to run local transactions, one way to do that without injecting errant transaction is to use set SQL log being equals 0, so that the transaction that you write locally on the slave will not end up in the binary log, so there will be no GTID associated with that transaction, so it's not going to be a problem with all the things regarding failover and so on. Another interesting thing is if you have holes in the GTID sequence. So holes are not allowed at all. So it is really strictly forbidden. Unfortunately, there are bugs. So for instance, you have one, second one has been fixed in 5.6.18. So the bug was when you had replication filters, well, you had holes. And when you have a hole in a GTID sequence, it can lead to issues very similar to those that you can have with errant transactions. So basically, it can lead to replication errors, so you break replication. The thing to know is that I don't know of any tool that is currently checking for holes in the GTID sequence. So that may be something that you want to script yourself. Another typical issue is I/O performance. So there are two aspects there. So the first one is that on all slave, as mentioned before, you have to enable logbin and log slave updates, which means that all the transactions are written in the binary logs on all servers, so all the slaves. Of course, this has some overhead. And the other thing is that if you remember, I said before that there's a mapping between a GTID and the actual position in the bin log, and this mapping is kept in memory. So what happens when you restart the server, for instance? You have a GTID, but you don't know in which file you have to find the corresponding GTID. So there you may have some performance problems because on the initial connect, the dump thread has to reverse scan the master's bin logs. So if, for instance, the slave is far behind in the replication stream, you may have to scan lots of bin logs and so do a lot of I/O. This is something to keep in mind. Okay, so next topic and last topic for the day, it is the new high availability solutions when you have GTID replication enabled. So here I will mainly talk about solution given brought to us by the MySQL utilities. So if you don't know MySQL utilities, it's a set of Python scripts that are meant to use the administration of MySQL servers. It's a script, it's a toolkit developed by Oracle, it's free open source, and you have the link to the documentation. So there are many tools in the toolkit, like, I don't know, 20, 30, maybe more. But the first one that is interesting for us when looking at HA solution with GTIDs is MySQL failover. So the tool provides health monitoring for a GTID-based replication cluster and automatic failover. The target topology is one master and n slaves, which is, well, the most common topology. So to use it, you have to use GTID-based replication, so turn on GTID mode, log slave updates, etc. You also have to enable a few extra options like report host, report port, and master info repository equals stable. Now, the tool can work in three main modes. So the first one is elect. So you give the tool a list of candidates for promotion, and at failover time, the tool will choose from one of the candidates. If no server from the list is available, it just exits with an error. The default mode is auto, which is exactly the same as elect, but if you don't find any candidate, it will choose any slave that is available. And you also have the fail mode, which only gives you health monitoring. So if as soon as the master fails, the tool will exit with an error and do nothing else. So let's see an example of an execution. So here we have MySQL failover. So to use it, we have to tell it where the slaves are. So one nice option is the discover slaves login option. So instead of listing all the slaves, you can simply specify an account. So here the user and password of an account, and it will try to discover the slaves automatically, and it works pretty well. And then, of course, we have to specify where the master is. So here we're specifying that the master is on localhost port 13001, and again we have a user with the username and password. And we're using the auto mode, which means health monitoring and then automated failover. So after starting the tool, what you get is this failover, this health monitoring console, where you can see some information at the top, and at the bottom you have the replication topology. So here, one master and two slaves, and you can see that everything is okay. Then now, if the master fails, after some time, the tool will detect that the master is down. So here you can see that, well, the tool tells us that it has not been able to connect 3 times in a row to the master. So now it considers that the master is down, and it will start to perform the failover. And you can see all the steps, and at the end, it has promoted a new master and reconnected all the other slaves to the new master. And it starts another console. This is the console when the failover is done. So same as before, but what you can see is that the server on port 13002 is now the master, and the other server is now a slave of the new master. And of course, the old master is dead, so we don't see it here. A few limitations of the tool. First thing is that the server on which you're running MySQL failover, so the monitoring node, is not highly available. So if you use that monitoring node, you lose your automated failover ability. So it's not as critical as So it may not be critical because if the monitoring node fails, well, it doesn't do any harm to your actual replication configuration. It still works. But the thing is that if the monitoring node is down, and if you don't know it, well, you can help not to have a crash, a master crash, because, well, of course, nothing will happen. So then you probably want to closely monitor the monitoring node. And for that reason, because the monitoring node is not highly available, you may prefer to use manual failover instead of automated failover. And for manual failover, there will be another tool that will be discussed next, which is MySQL RepLadmin, so also from the MySQL utilities. So of course, errant transactions can prevent failover, as we saw before. So it can be useful to use the -- pedantic option, because if you use that option, you'll get an error when starting MySQL failover if you have an errant transaction. It's probably much better than letting the tool do a failover and then, oops, realizing that it will break it will break replication. So if you have an error transaction, so if you want to be safe from errant transaction issues, use -- pedantic. If you see an error from MySQL failover, then of course fix manually your transaction by inserting an empty transaction. So now MySQL RepLadmin. So the tool works pretty similarly to MySQL failover, and you basically have two ways to do slave promotion. The first one is planned promotion, which is called switchover. So how do you use the tool for switchover? MySQL RepLadmin, then you tell the server, you tell the tool where the master is. So same syntax as before. Here the master is at on localhost port 13002, and we have a user root with password root. We tell the tool that we want a new master, and we specify which server is going to be the new master. And we can also say that we want the tool to automatically discover the slaves with the -- discover slaves login option. And we can also use the demote master option to make sure that the old master will become a slave of the new master. And then you specify the command, which is switchover. So this will trigger slave promotion. And then if you have a master crash, you'll have to do a promotion that is unplanned, and that is called failover for MySQL RepLadmin. So here the syntax is a bit different because, of course, as you no longer have the master, it's not possible to say, well, connect to the master and automatically discover the slaves. So here you have to specify all the slaves. And you also have to specify all the candidates. So here we have 2 slaves and 1 candidate, and MySQL RepLadmin will use that to rebuild the replication topology. Another tool from the MySQL utilities is MySQL Fabric. So it's available from MySQL Utilities 1.4. Of course, it's a much so the tool is not limited to HA, and it's a much broader tool. So there are lots of things you can do with MySQL Fabric. So it's not possible to explain that in this webinar. So the official documentation says that it's an extensive framework for managing forms of MySQL servers. So you can see that you can do a lot of things. And a few weeks ago we had a webinar on Fabric. So if you're interested in that topic, you can listen to the recording. Other solutions, so over from the MySQL utilities, you can use MHA, for instance. So MHA from the last version, 0.56, is supporting MySQL GTIDs. So you can use it. We also have the Pacona replication manager, which is based on Pacemaker, which now supports GTIDs. So these are solutions you can use with GTID-based replication. However, one thing to keep in mind is that neither MHA nor PRM do checks for errant transactions. So, of course, you can use the tool and it can work perfectly well, but if you have an errant transaction, well, failover can be dangerous, okay? Because you can break replication with the tool. So you should be aware of this very significant limitation, right? Just before we go to the Q&A part, let me say that let me mention that we have our annual European conference in London in November, and we have an interesting rate for registration, which ends August 31st, which is at the end of the week, if I'm right. So if you're interested, you have the link to register. And now I think we have some time for the questions. So Alisa, back to you for the questions.
Hi, Stefan. Can you hear me okay?
Yep, I can hear you okay.
Okay, great. So the first question is active-active master-master successful in MySQL with GTID?
So GTID replication is really another way of tracking the transactions. So instead of having binlog file, binlog position, which are different on all the servers, you have a unique identifier everywhere. But it doesn't change anything about the limitations of replication. So it's still asynchronous, it still doesn't support active-active. So you can, so short answer is active-active, so dual active-active replication is not supported, and GTID doesn't change anything. And of course, we know some people doing it with some success because, well, there's nothing preventing you from doing that, but it's very dangerous. So it's highly recommended not to do that.
Okay. The next question is, what is the difference between GUID and GTID?
So I don't really know what GUID is. So maybe maybe I'm going to skip this question and keep it for the forward blog post because right now I'm not really seeing what it is.
Okay, fair enough. And everybody, if you want to type your questions in, well, like I said, we'll get to as many as we can, and those that Stefan does not answer or needs to do research on, he'll answer in a follow-up blog post on our MySQL performance blog. Okay, so the next question is, what is the value of saving the history of previous masters' GTIDs executed in the show slave status? Executed GTID set.
So it's really related to how the new replication protocol works. So as I mentioned, when the slave connects to the master, it sends the range of GTIDs it has executed, and then the master sends all the other transactions. So it means that the slave has to keep track of every transaction it has ever executed. So that's why it's recorded like this.
Okay, next question. Can the errant transaction issue be prevented with active-passive master-master replication?
Well, not really. So the issue is that in the MySQL world, there's really nothing preventing you from writing locally on a slave. So of course you can implement safeguards like setting all slave as read-only slaves. But if you have the super privilege, you can still write on the slave. So there's no topology that can avoid errant transactions for sure. So the best thing, of course, is to make sure that all scripts are written safely, so are going to the master. Make sure that the users don't have unwanted permissions, so that, well, if they connect to a server, to a random server, and try to write something, well, it should not be allowed. But of course, well, the DBA itself, which will have the super privilege and all the privileges, may make a mistake, and then he may write something on a slave.
Okay, great. Next question. There's several questions about getting a copy of this presentation. After we're done today, I will go ahead and process and send everybody here a link to both the recording and the presentation slides, so you should have that within 48 hours. All right, so the next question is GTID subset function part of MySQL utilities, or should we set a script to regularly detect it?
So GTID subset is a built-in function in MySQL. So you don't need to use MySQL utility to be able to use the GTID subset function. And the main goal, so the initial goal of this function is to be able to compare two sets of GTIDs. And here I've shown how to use it to detect errant transactions. You can probably do that in other ways. Now, regarding MySQL utilities, so mainly MySQL failover and MySQL RepLadmin, which are tools related to both GTID-based replication and failover, they both do checks for errant transactions. So they're safe to use. They're pretty safe to use with errant transactions, because if you have an errant transaction and if you try to do failover, the tool will tell you, you have an errant transaction. Are you sure you want to do the failover? So then it's going to be up to you to say yes or no. But at least the tools will warn you. And for instance, this is the issue that you can have with MHA. So it doesn't check for errant transaction. So if you have one, do failover, well, replication would be broken. So basically, if you're using MySQL failover or MySQL RepLadmin, you don't have to do an extra script before failover to make sure that you have no errant transaction. But what you can do, of course, is having MySQL failover, being responsible for automatic failover, and having an extra script that you will write that will detect errant transaction and that will warn you, or that will fix the errant transaction. It really depends. It's really up to you.
Okay, next question. Will GTIDs work well with master standby master, and how quickly would the failover be?
So I guess it can be either a master-slave topology, so one master and then the slave is a standby, or master-master with one active server and one passive server. So the thing here to remember is that GTIDs per se are not an HA solution. So GTIDs don't provide any any mechanism for failover. So GTIDs are just a way to identify transactions. The good thing is that with GTIDs you can build tools that are, let's say, pretty easy to code, and that will be able to deal with the replication reconfiguring, etc., etc. So all the things that makes a failover difficult. So the time to be able to failover is really dependent on the tool you're using. So for instance, with MySQL failover, you can configure the time between two checks, and I think the minimum time is 5 seconds. And you can also configure I'm not sure you can configure the number of attempts before a master is considered down. But by default, if you're using 5 seconds and 3 attempts, it means that the master will be considered as crashed after 15 seconds. So you have at least 15 seconds of downtime, and then you have the time to promote choose a new master, promote it, reconfigure the slaves. That should be pretty quick, but that may take 5 seconds, 10 seconds, 30 seconds, so sometimes it may be 1 minute. But if you do your own tool, and if you have different threshold, and if you do things differently, it can be maybe much faster, or it can be, of course, much slower if you do things differently.
Okay, and go ahead and type your questions, and we have quite a few, so I'm going to try to get to as many as we can in the time we have left. All right, so the next one is, what are any practical advantages of using GTID with MHA?
Well, that's a very good question. Basically, I'd say that MHA does a lot of things that GTIDs do. So when you have MySQL 5.5, so no GTIDs available there, and if you have a complex replication setup like multiple levels of replication, having a tool like MHA can be very useful because it makes replication reconfiguration much easier. Same thing if you have master slaves with lots of slaves. MHA will do all the hard work for you. If you have GTIDs, well, basically GTIDs are doing or allow you to skip all the hard work done by MHA. So I'd say that the value of MHA when using GTID is that, well, it's a script that is already written. So if you want to have a script to do failover, well, first solution is to write your own scripts. Second solution is to use a pre-existing script. MHA is one of these pre-existing scripts. So this is where MHA can be interesting with GTIDs. But for sure, to be honest, MHA is much more interesting when you have no GTIDs, so for MySQL 5.5 and older versions.
Okay, next question. Applications having tables from different engines such as InnoDB and MyISAM, how is that handled in GTID?
So as you have probably seen during the session, I've talked a lot about transactions. So the goal of GTIDs is to keep track of transactions. So it's really InnoDB, focused on InnoDB. So it can work with MyISAM, I think, But the thing that you should not do is to mix transactions with transactional tables and non-transactional tables. And for instance, this is the goal of the enforce GTID consistency setting, because you may have problems when using GTIDs with transaction on both MyISAM and InnoDB tables. So with that option, it won't be possible, and it will make your work much easier. But anyway, it's recommended not only for GTIDs but in general to use InnoDB only if you can.
All right, we've got time for a couple more questions. We use DB master and slave VIPs on our servers. Can the MySQL failover tool also switch the VIP to the new master?
Yeah, we can do that. So what you have with both MySQL failover and MySQL REPL admin is a few settings to give you extension points. So you can say, well, after failover, execute that script. And in that script, of course, you can do anything you want. So write an email, change a VIP. Well, it's really anything you need. So you can do that with both tools. So by default, MySQL, both MySQL failover and MySQL REPL admin are only dealing with the failover at the MySQL level. They don't know about the rest of the application. But with these extension points, you can add your own code and do the things that you have to do at failover time.
Okay. And here's one more question. How does MySQL failover handle brief network instability between masters and slaves?
So I may be wrong here, but the MySQL failover only performs health monitoring on the master. So the main thing is that if you have network problems between MySQL failover, so the monitoring node, and the master, MySQL failover may wrongly consider that the master is down and trigger failover. If you have network issues between the master and some of the slaves, I think MySQL failover will not notice that.
Okay, and this is the last question for today. And like I said, please don't worry if Stefan didn't get to yours. We will definitely do a follow-up blog post. You may have already answered this question, but I thought I'd just ask it again. If we set slaves to read only, is that recommended to eliminate the errant transaction?
So it's recommended because it avoids many issues with people or scripts writing on the slave instead of writing on the master. Unfortunately, as long as a user, so an account, has the super privilege, it can write on a slave even if it's set as read-only. So if, for instance, all the users are using the root account, well, there's no point in setting read-only. But if you have designed your user accounts carefully, then yes, it can be useful. So it won't avoid all the errant transactions, but it may avoid, most of the potential problems with the errant transactions.
Okay, that wraps up our Q&A session for today. Stefan, thank you so very much for a great webinar. And audience, thank you for joining us today. Our next webinar is going to be on September 10th, and it's called Migrating to Percona Extra DB Cluster. It's an update from a webinar given almost 2 years ago, and it's very, very popular even now, so we thought we'd give an updated version. Anyhow, thank you so much for joining us today. Like I said, I'll get a copy of this recording and the presentation to everybody within 48 hours. And I hope that everyone has a great afternoon, morning, or day, depending where you're calling in from. Stefan, thanks again.
Thank you.